In this video, we're going to cover mounting a couple of the peripherals that are necessary for this year's game. That will be the Raspberry Pi camera as well as the flow sensor. So we have in our DEXI 3D Prints repo and AVR compute kit parts. I'll direct you to the new teams folder, and we want to make sure that we print 2 of the AVR left mount rods. So 3D print 2 of these, recommend an infill of 50% or more, and 2 of the right mount rods. So that covers the mounting rods. We'll do an ARK flow bottom case, just one of these. Our flow sensor will mount in here, as well as the top case to fully enclose the ARK flow sensor. And then finally, the AVR camera mount. Print one of these. So 2 left rods, 2 right rods, 1 bottom case for the flow sensor, 1 top case, and then 1 camera mount. Now that we've reviewed the 3D printed parts for this phase, before I flip the drone over, let's cover what we've gone over so far. So we've installed our telemetry cables, TLM1 to UART0, TLM2 from Pixhawk to UART1, and of course the LED connector. Now I'll go ahead and flip my drone over. You'll see our 3D printed rods are secure. Now these are coming off the left and the right side of the bottom plate. And the reason is, in this year's challenge, you'll have payloads, various payloads, connects beneath the drone. And so this allows us to get both the Pi camera and the flow sensor outside from being obstructed by that Connex box. Now you're free to modify this as you like, but this is sort of a reference design that we are providing for you guys to work with and work around. So that being said, you'll notice that each of these rods connects, one with the M3 bolt that goes to the standoff and the other that goes through to the battery tray. I'll start with the flow mount. As you know, this is 2 pieces. I put the flow sensor in, put the top case on. Now, I didn't have at the time screws long enough to go all the way through, so what I did is just a little bit of hot glue in each quarter to hold that in place. So what I have here is the front of my drone pointed off to the right, and you'll notice these connectors on the flow sensor. We want those facing the rear of the drone, and what I can do is just slide this on. And then, as you recall, we previously connected this to the CAN port on Pixhawk. So this is a 4-pin connector. I'll go ahead and tilt this up. Our flow sensor is mounted now. Keep in mind, this is a bit of a friction fit, so it might loosen over time. So I'd recommend either zip ties or something to secure it into place, and in an upcoming video we'll actually cover the offsets to be able to make sure that we specify the offset from the flow sensor to the center of gravity, if you will, and that will allow us to get a better position hold. So this flow sensor's job is to give us position hold. That means the XY, holding it in position on the XY plane, as well as the Z or the altitude with a time of flight sensor that's looking at the ground. So we want to make sure that we get this nice, securely mounted, and once again we'll configure this in an upcoming video. Let's cover our Pi camera mount. Simple press fit, and then once again these cutouts are holes to slide on these rails or rods. So I'm going to go ahead and place this on with my USB-C connector facing outward. You can make that work however you like. We also have the ability within our ROS code to rotate this image 90 degrees or 180 degrees, any direction that you prefer based on the mounting of your camera. So I've gone ahead and clicked that into place. You'll see here, we know that this cable is a little bit longer than necessary, the one that comes with this ArduCam, but I've gone ahead and zip tied that to the frame. And on the other end, from the camera cable, we are connected to the USB port on the Pi. Now there are two USB 2 ports, the black ones, and then two USB 3 ports, the blue ones. Camera currently does not need support for USB 3. You can certainly use it, but here I have it plugged into the USB 2 port. And what we have is the nose of our drone with the flow sensor on the right side, Pi camera or ArduCam over here on the left side. And I'll wrap by saying that once again, these are reference designs and locations for these sensors, but you're more than welcome to modify based on your design for your payload pickup and drop off. In the next video, we're going to load a new version of PX4 and configure our ARK flow sensor for position hold.